All right, guys, 8-6, geometric sequences. We are going to form geometric sequences, finding the common ratio and using that knowledge to find what those sequences are. And also we're going to use those formulas when describing geometric sequences. All right, so finding the common ratio is probably one of the easiest things that we're going to be doing in this particular section. At least I think it is. Um, and I guess that would be relative, right? Okay, so 3 to negative 15, what are we doing? Multiplying by negative 5. Negative 15 to 75, multiplying by negative 5. 75 to negative 375, multiplying by negative 5. And we know we're multiplying by a negative because it goes positive, negative, positive, negative. If it were all positives, then there would be no sign. And a negative times negative is positive, so that's how we're getting the alternating. So your common ratio of A is multiplying, I'm going to go ahead and write that, multiplying by negative 5. All right, little fraction bars, they like to play hide and seek sometimes. Okay, so now taking a look at B, what are we doing to this 3 to get 3 over 2? What are we doing to 3 over 2 to get 3 over 4? Or 3 over 4 to 3 over 8? Let's go ahead and take these two. Ooh, heavens. Um, let's pretend I can be a better artist. All right, while we're pretending, let's go ahead and take this out. 3/4 and 3/8. What am I doing to 3 to get 3? We're just multiplying by 1. What am I doing to 4 to get 8? We're multiplying by 2. So this would be multiplying by 1/2. And to check that out, we'll take a look over here. 3/2 times 1/2. 3 times 1 is 3. 2 times 2 is 4. And bingo, that's what we get. So our common ratio is going to be multiplying by 1/2. I want you guys to see if you can always find the term in terms of multiplication because it makes it easier on you. You could say dividing by 2, but like I said, I just think it's easier on you and it's a good habit to start developing it as a multiplication ratio. All right, example 2, finding the next term in the sequence. All right, well, we need to identify the common ratio before we can identify the next terms in the sequence. Fortunately, they were gracious enough in this particular thing. I don't think this is supposed to be here. I think I accidentally copied it over. But we have the common ratio listed for us, but it would have been easy. We would have gotten this one. It is -2, so we need to continue this sequence on and find the next 3 terms. So -40 times -2, negative times negative is positive, 40 times 2 is 80. 80 times -2, that's going to be a negative. 80 times 2 is 160. We're going to multiply this one by -2, and this becomes 320. So there you have it, the next 3 terms of the sequence. Now you are going to see problems like this on your EOC, so you definitely don't want to just shrug this off and say, it's baby stuff, because you will need it. All right, now some of you look at me like I had grown another head or something when I said this term, but it is arithmetic. I say arithmetic and geometric. Arithmetic. When we're talking about sequences, when we are describing that, using that as an adjective as opposed to a noun, it has a slightly different pronunciation. So either an arithmetic sequence or a geometric sequence. The difference between the two is pretty easy to determine. Arithmetic, you are adding, or you can think about subtracting. Geometric, you are multiplying, or dividing. But remember, subtraction is just adding the negative, and dividing is really just multiplying by the reciprocal, right? So remember those two things, and here we go. 162 to 54, 54 to 18, 18 to 6. Well, this is the one that I know quickly without anything else. 18 to 6, I'm going to be dividing by 3. 54 to 18, if I test that one, we're dividing by 3. 162 to 54, we divided by 3. Or we multiplied by the reciprocal, 1 over 3. But we don't need to find any of that. We just need to determine if it's arithmetic or geometric. Since we're talking about multiplication and or division, this one is geometric. Now looking at 98, 98 to 101, 101 to 104, 104 to 107. 104 to 107, we added 3. 101 to 104, we added 3. 98 to 101, we added 3. Because we are adding, this one is going to be arithmetic. Okay? All right. Example 4. Finding the terms of a sequence. Okay, you are going to need to know this. You, again, will see something like this on your EOC. They have the sequences and they also have recurring sequences, which is similar but different. But hopefully when you're looking at 8-7 and 8-8, you can see how very similar the exponential functions all are, even though they might mean something slightly different. Okay, so we have the geometric sequence, the rule. Down here for your notes, example 4, it says find the first, find the fifth, and find the 10th. So we want 1, 5, and 10. The terms of sequence that has the rule a of n equals -3. Oh, sorry guys. -3 times 2 raised to the n minus 1 power. All right, so when n is 1, we have a sub 1, sorry, not a sub 1. A of 1 is equal to -3 times 2 to the 1 minus 1 power, because this goes in right here. 1 minus 1 is 0. Anything to the 0 power we know is just 1. So this is -3. Okay. If n is 5, then we have a at 5 is equal to -3 times 2 to the 5 minus 1 power. And again, this 5 is coming from here. And this should be the same here. This is just telling us where that function is. This is your y coordinate. All right, 5 minus 1 is going to give us 4, right? So now we have to use the calculator. I guess we don't have to, but definitely makes life easier on all of us. Sorry about that. It wasn't working. It freezes up on me after a while. All right, we have negative. You want to use this negative. You don't want to use the subtraction. -3 times 2 raised to the 4th power, and hit enter. -48. So this, at 5, or I'm sorry, the 5th term is -48. All right, and then finally, when we're looking at the 10th term, when n is 10, that means a to the, or I'm sorry, a of 10 is equal to -3 times 2 to the 10 minus 1 power. And we substituted in that 10 for the x. 10 minus 1 is 9. So now going back to the calculator, we have negative 3 times 2 raised to the 9th power. And that gives you negative 1,536. So negative 1,536. So this is your first term, fifth term, 10th term. All you're doing is plugging in those values into the equation and solving it. That's it. You're not doing anything else. You're not having to rewrite anything. Pretty easy. Okay. The last example that we have is the real world problem, and there is no extra additional one for your notes. So I'm going to go ahead and turn this off. You can take a look at this in your book. If you have questions, please let me know.